Okay, sufficient weight. No, about 40 of us in the class. Assalamualaikum, brothers and sisters.
Waalaikumsalam.
Yeah. Let's start our day with the recitation of Ummul Kitab Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Arrahmanir rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, let's start our day with a dua. Now, request Ustaz Farhan, please. Al-Fadil Ustaz Farhan, are you there?
Yes, okay.
Yeah, tafadhal Ustaz. Bismillah.
Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya wa mursalin wa ala alihi wa sahbihi ajma'in. Allahumma aftah alaina hikmataka wa anshur alaina min qada'ni rahmatika ya arhamar rahimin. Rabbi shrah lana sudurana wa yassir lana umurana wa halu 'uqdatam min lisanina yafqahu qawlana. Allahumma alhimna ilman na'rif bihi awamiruka wa na'rifu bihi nawahiyaka warzuqna. Allahumma balaghata fahmi an-nabiyyin wa fasahati hifzil mursalin wa sur'ata ilhamil malaikatil muqarrabin wa akrimna. Allahumma binuril ilmi wa sur'atil fahmi wakhrijna min zulumatil wahmi waftah lana abwaaba rahmatika wa allimna israr hikmatika ya rabbal alamin. Amin ya rabbal alamin.
Amin ya rabbal alamin. Thank you, Ustaz. Okay, let's continue from what we have done in the last class. What did we do last class? We are having fun, right? We are enjoying ourselves. Let's continue. EVPI. You see EVPI. Okay, just recap a little bit. We have done in the last class, Maximax approach. What else? Minimax, criteria of realism, minimax regret,
probabilities,
expected value, and then expected value of opportunity loss. 6 method. Now, when we do decision analysis, the previous class, the expected value, we just make our own estimate. Maybe the organization is creating their own estimate about the probability of the states of nature. Like point 8, states of nature 1, strong demand. Point 2, weak demand. This is just an estimate from our own organizations. Maybe this time we need a more accurate information. We engage a consultant. We engage a consultant to find what we call it expected value of perfect information. So in decision making, we are looking into this expected value with perfect information. That means we are going to engage a consultant to advise us about the future states of nature. So we ask somebody to find what we call expected value with perfect information. We engaging a consultant or specialist to analyze and to reaffirm the expected value that we have created. And then the expected value that we have done earlier, this expected value without perfect information. That means the expected value obtained without the help of any specialist. So that's our own working. And this time we get a specialist to advise us. And now we want to compute what we call it expected value of perfect information. So expected value of perfect information, EVPI. equals expected value with perfect information less expected value without perfect information. Okay, what does it mean? Okay, let's look back at what we have done earlier. This is the payoff table that we have done in last class. Now we are going to calculate what we call the expected value with perfect information. How to do this? Since it is supposed to be perfect, so we assume this probability of strong demand 0.8 is perfect. And we also assume that the probability of weak demand is perfect at 0.2. Since the probability is assumed perfect, then we try to look for the best payoff from the three different alternatives. In this case, the best payoff is 20. And then the same goes for this one. And the best payoff for the weak demand is 7. Then we also calculate, so 20 times 0.8 or 0.8 times 20 plus 0.2 times 7. So we get this value. So this value is 0.2 times 7. This one, this 16 is 0.8 times 20, 16. We add them together. We have total 17.4. This is referred as expected value with perfect information. And now we are going to calculate what we call expected value of perfect information. What was the formula again? Expected value with perfect information minus expected value without perfect information. Okay, this is what we are going to do. So this is the expected value with perfect information we just computed. This is the expected value without perfect information that we calculated last class. This one. We choose this one, 14.2. And this is this is the value. And then we calculate expected value of perfect information equals expected value with perfect information less expected value without perfect information, 17.4 less 14.2, 3.2. And then if we look back what we did last, expected value of opportunity loss, we get 3.2. Let's look back. This is what we did. EOL 3.2. Now look at this number, 3.2, 3.2. So we have another way of looking at it. AVPI equals minimum expected opportunity loss. Now, if there is this specialist, if this specialist wanted to charge you, because you engage a specialist, they are business people, they want to charge you 3.5 million for their work. Will you get them to do your work? Say these people charge you 3.5 million. Then what you are getting more by getting these people is 3.2 million more. We are still warming up. What if this consultant charge you 200,000? Will you engage these people? Will you appoint these people to conduct the research for you?
Yes, there's still a profit there.
Still profit. How about if he were to charge 3.5 million?
No.
No, forget. No, forget about this guy, right? You can tell them can fly kite. So if there is an exam question, how much maximum are you prepared to pay this consultant? That means you don't get anything. That means the answer is 3.2. This is a typical questions in exam. How much are you prepared to pay? I mean, that means you get nothing. You just pay this off, 3.2 million. But the idea is not like that. The idea is we try to have to pay them less than 3.2 million. That means maybe 200 or maybe 100. Okay.
Doctor, I have a question.
Yeah.
So, does that mean by engaging the consultant and analyst, it means that they come up with the probability? Is it fixed or is it depend on them?
It can be different from 0.2, 0.8. It depends on them. Yeah, it depends on what their finding is. And these people supposed to be a good analyst. They are supposed to be well equipped with all the probabilistic informations, and they have developed certain psychometric formula, whatever, to develop this probability. So this 0.2, 0.6 is just for illustration purpose, but the concept is these people are coming up with the best, what we refer is as perfect. Okay, do I answer you, brother? I hope so.
Yeah. So does that mean the value of EVPI does not, does not absolutely equals to minimum of EOL?
Uh, Always you will get most of the time equal, because the probability is the same, but it can differ also, as what you said. If they come up with the perfect information at say 0.7 and 0.3, then it will be different. But typically it is the same.
All
Okay.
right, sure.
Okay, let's move on what we call sensitivity analysis. What is sensitivity? If I were to tickle Brother Ayman, what will be his reaction? I were to tickle him at his armpit, what will be his reaction? Laughing away, or he jumped up to the ceiling? Is that
Oh,
sensitivity?
yeah.
Is that the sensitivity we are looking at? No.
No,
Yes or no? Yes, no. We are not going to tickle brother. Okay, let's look at sensitivity analysis. Sensitivity analysis, we are exploring what if scenario. Exploring what if an approach used to determine how changes in the probabilities of the states of nature or changes in the payoff affect the recommended decision alternative. Let's say the probability change, what happened to your decision? Your decision may change, and it may affect your payoff also. So it is a situation of what if situation. It is what if analysis. Okay, let's look at our problem. What if probability of strong demand is 0.8, probability of weak demand 0.2. Let's use expected value approach. What will be your decision? Obviously, you know the answer. You will answer D3, construct D3, because the expected value highest is 14.2. Okay, what if, again, the probability of strong demand is 0.5, weak demand is 0.5. You think you make the same decisions? Okay, let's see what will happen. What will be your decision if the probability of strong demand 0.5 and 0.5 instead of 0.8 or 0.2, now 0.5 and 0.5.
You take the medium.
Medium. Okay, you will decide medium. Yeah. Okay. What if, again, if the probability of strong demand is very bad, 0.2, if the probability of weak demand is very high, 0.8. So what will be your decisions? Okay, we do the same, calculate the expected value. What will be your decision again?
Just put the small one.
D1, right? D1. Okay, now look at this. Now, at what probability value, like here, because based on this, what if your decision change? At what value of probability of states of nature 1 will you change from D3 to D2? Or at what probability of strong demand your decision will change or shift from D2 to D3? How are you going to do that? Are you going to analyze? Let's try 0.75, 0.7, 0.65, 0.6, 0.55, and so on. And you try every numbers of this one. Are you going to do that?
No, there's too many to try.
Too tedious. I think we are all not that hardworking, right? I'm not saying we are lazy. We are trying to find, is there a shortcut, right? Yes. Okay, let's look into this scenario first. Let's have two probabilities, strong demand and weak demand. Probabilities always add to 1, right? We always agree with this. If the probability of states of nature, we put, instead of a number, you put a variable P. Now, if P, probability of strong demand is P, probability of weak demand will be 1 minus P.
Yes.
Yes. Now, if P will range from 0 to 1, not 0 to 100, unless you refer as percentage. If probability of strong demand is 0.8, and P is 0.8, what will be PS2?
0.2.
0.2. So then PS1 will be 1 minus 0.8, 0.2. This is what you did already. So now let's develop an equation. This is the same thing. If the probability of strong demand is P, the probability of weak demand is 1 minus P. So using back at our expected value calculations, now instead of 8 was the payoff for strong. Now look at, we are computing expected value of strong, D1, decision alternative 1. 8 was the payoff for strong demand. 7 was is the payoff for weak demand. So 8 times probability, the probability now instead of a number, we put a variable. So 1 minus P is weak demand. So we are computing this one using this one, and then we develop a mathematical equation, something like this. Same thing for decision number 2. 14 was the payoff in strong demand, 14 times P. 5 was the payoff for weak demand, 5 times 1 minus P. Simplify, you get 9P plus 5. The same goes for decision alternative number 3, D3. The payoff for strong demand was 20. The payoff for weak demand, you lose 9, negative 9. And then this is the probability of weak demand, 1 minus P. Then simplify it, 29P minus 9. So we have 3 sets of equations. So what are we going to do with this set of equations? So this is the 3 set of equations. We are going to plot this.
We solve it.
Yeah, again.
We are gonna have to solve it simultaneously, but we are not given the.
Yeah. Yes, we are going to solve this. So, but the first thing is we are going to, well, you can solve straight away, the better. But for illustration purpose, let's plot a graph where the vertical axis is the expected value, and then we have the horizontal axis, the probability. probability range from 0 to 1. This is point at the origin O. This is point C somewhere here. So we are going to plot this equation 1. If P is 0 at this line, at this point, P is 0. What is the expected value? If P is 0, 7. So let's say we mark somewhere here, 7 is 7. The same go for this side. If at this point, P is 1. If P is 1, what's the expected value for D1?
8.
8. Simple mathematics. So we 8. Then we, since it is a, what equation is? Linear equation, right?
Yes.
Linear, not circle, not curve, so linear equations. So we are going to plot a straight line across this. So this is straight line. This straight line represents the profile of expected value for D1. If P is 0, the expected value is 7. If P is 1, expected value is 8. If P is 0.5, is somewhere here. Maybe 7.5, not sure, just guessing. So the same go for the second equations. If P is 0, expected value 5. And then if P is 1, 14, right? Straight away. And this one become easy, straightforward. The same thing, we plot the profile for expected value for decision alternative 2. Then we plot the same thing for decision number 3. If P is 0, -9 here. If P is 1, you get 9, 20. Is it right? I don't know. 20, 29 minus 9, 20. So we plot. So what it says here, between here and here, what will be your decision? Between here and here, the highest expected value is somewhere along this line. From this probability to this probability, your expected value, the profile of the expected value is somewhere here. That means somewhere to here, your decision will be something. So if I were to tell you, if P is 0.5, what will be your decision? The highest will be D2, right?
D2.
D2, because this is the highest profile. If I say 0.8, if P is 0.8, somewhere here, say
D3.
D3. If P is 0.1, somewhere here.
D1.
D1.
So now, from here to here, here to here, here to here, what is that here? What is this here? So you want to know?
The intersections.
This one. So you know this is the point. I mean, this, what do you call this point?
The
Anyway,
intersection between these
okay. So this one is equation this and equation this, right? D1 and D2. And that's what Brother Sister Sadia said just now. Are we going to solve this equation? Yes, we are solving the equation now. Let's find the value of the probability at this point. Solve these two equations. So we have this P plus 7 plus equals 9P plus 5. So we have these two equations, and we get the value of the probability 0.25. Right? Yes. I assume you are following. Okay. How about this one? Do we have to do anything at this point?
Yes.
Yes.
No.
No, because this is not on the highest profile. We want to look into the higher profile only. So we are not interested at this one. We are interested at the higher value. This is higher value, higher value. So at this point, your decision will shift from D2 to D3. So, so what will be the value here? Okay, we do the same. Solve the equations. We get 0.7. We don't waste time calculating. I think you know how to do this. So we get this point, 0.7. So what it says here, if the probability range from 0 to 0.25, you will make decision D1. If 0.25 to 0.7, D2. 0.7 to 1, D3. So as soon as somebody say 0.75, you know your decision will be. Okay, let's say, what will be your decision if P is 0.2?
D1.
D1. What if P is 0.3? 0.3?
D2.
D2. What if P is 0.25?
Either D1 or D2.
Yes. Both.
Either D1 or D2. So what it says here, if P is at 0.25, you can swing from D1 or D2, right? So at
Yes.
this probability value, your decision is very sensitive. That's what we call sensitive. At this point, your decision can swing from one to another. The same goes, where's another sensitive point? 0.7. 0.7. So at this point, this is also the most sensitive. Your decision can swing from D2 to D3. So this is the idea of sensitivity analysis. But for our purpose, for class purpose, normally we have two probabilities only, because we want to have these simple linear equations. So this is the outcome of the sensitivity analysis. This is how we write. When P, you will make decision on D1 when P belong to this symbol, euro symbol, belong to 0.2 up to 0.25. D2 when probability of strong demand is between 0.25 and 0.7. D3 when the probability of belong to 0.7 and 1. Okay, remember P represent the probability of strong demand. Okay. Any question? Not so difficult anyway. Just now we did EVPI. EVPI. What was it? EVPI. What does it stand for?
Expected value of perfect information.
Of perfect information. Expected value of perfect information. Now, if we always hear some people when they are not, they are critically sick or what, they will see a doctor, and the doctor has an opinion, certain advice. You think these people will agree with the doctor? Let's say the doctor somehow diagnosed, oh, you have cancer. You think this patient will straight away agree, or do they think of somebody else?
I think
They make
straight away.
something to assume.
They get somebody else to give a second opinion, right? Second, they may see another doctor in Singapore. They say, oh, this is just a simple infection, not really cancer at all. So in situation like this, we are trying to get another source of information. So we are going to do what we call it decision making with sample information, or decision with additional information. So in this case, we are going to engage another consultant. So the probability information about the states of nature affect the expected value calculation, and thus the decision also. Same thing. So what we do is we are going to look at the probability value of the future states of nature. The one which we did earlier, we call this prior probability. The prior probability of the states of nature. And then now we engage another consultant, maybe to do a survey, to do more analysis on the probability, the probability of the future states of nature. So engage another expensive consultant. So this consultant will conduct a survey or get new information or obtain some experiment if necessary, and use this to revise or update the probability so that they get a more accurate probability of the states of nature. And this new probability, we call it posterior probability. So we take note, prior probability of state of nature, posterior probability of states of nature. So we have to calculate this. And then this consultant, when they do, they may come up with a very nice report for you. And the report may be error-free, no mistake, or maybe some error in the report, or maybe they have some oversight in their analysis. So we refer this as one, maybe there is some error or no error. If no error, we call it favorable report. They come up with a thick report for you to study. And then if there is some mistake or some error, let's refer this as unfavorable report. So we will use this information using Bayes' theorem, and we are going to calculate the posterior probability. Let me intimidate you. This one, probability of S1, strong demand, under condition of favorable report, is given by this formula, probability of states of nature 1. This is the prior probability, times, this is John probability, times probability of favorable report under condition of strong demand, divide by the sum of the two joint probabilities. Okay, let me intimidate you more. Okay, you have 4 sets of this one. Look at the yellow one. Look at the yellow. Favorable, favorable, strong demand, weak demand, S1, S2. Look at the top, PS1 times PF/1. This one, the second one, P, probability of weak demand. This is PS2, prior probability, probability of favorable report under condition of weak demand, S2. So this is one pair, and this is another pair, unfavorable report. So let's say it's a market report. So that means it says, if we calculate this value, say 0.6, that means there is a chances of which one? PF. PF, if say 0.6, we refer this as 0.6 favorable report, 0.4 unfavorable. That means a probability there is a mistake. That means 60 chance probability. Then probability of unfavorable report. That means there's a say 40% chance of occurrence, or there is a probability of mistake there. Not necessarily there's a mistake. It's just a probability. So what we are going to do, we are going to calculate the posterior probability. This is the information given by the market research. They say under states of nature 1, strong demand, these people tell you there's a 90% probability that the report is favorable, provided it is strong demand. And then there is a likelihood that the probability of error or unfavorable with states of nature 1 under condition of states of nature 1, 0.1. Similarly, weak demand, probability of favorable report under states of nature 2, weak demand, they give you 0.25. And the probability of unfavorable report, or maybe there's a mistake in the report, under condition of states of nature 2, S2, is 0.75. And this is the earlier report, earlier probability that we have computed earlier. We use this 0.8 and 0.2. So we are going to calculate another probability. We call it posterior probability using this market research information. So take note, this is the prior probability. These are all the conditional probability given by the market research people, by the consultant. Okay, now let's calculate. You are good at calculate. So we are going to calculate posterior probability. You look back at the formula. We just tabulate like this. Take note, S1, S2, state of nature 1, strong demand, state of nature 2, weak demand, probability of strong demand, 0.8, probability of weak demand, 0.2. This is this one we refer as prior probability. And these are the conditional probability given just now. 0.9, probability of F, S, probability of F, S1, 0.9, probability of F, favorable report, S2, this one. Okay, let's revisit the thing. This one. Take note again. The upper one is PSFS. Okay, take note. PF S1, PFS, PFS1. Okay, look at it again. The second, for this line, for the second one. PS2, PFS2. PS2, PFS2. PS2, PFS2. Then what are we going to do with these informations? We are going to multiply this and this one. I refer this as joint probability. So multiply this and this, 0.8 times 0.9, straightforward, you have the answer, 0.72. The same thing, 0.2 times 0.25, of course, 0.05. Okay, look at this formula again. Look at this one and this one, the same. This one and this one and this one, the same. So at the bottom here, actually, is the sum of the joint probabilities. This one plus this one. So at the denominator, actually, the sum of the joint probabilities. So in this one, the sum of the joint probability, 0.72 plus 0.05. You get 0.77. And this is referred as probability of favorable market report. That means the chances of no mistake is at 0.77. Then we are going to calculate the posterior probability. Look at this again. This one divided by sum of joint probability. Okay. The denominator, the numerator, 0.72 divided by sum of joint probability. 0.72 divided by 0.77, we get 0.94. And this is referred as posterior probabilities. We refer as probability of strong demand under condition of favorable market report, F. The same goes for the second one, 0.5 divided by 0.77, get 0.06. This will be PS2 over F. That means the probability of weak demand under condition of favorable market report. So we will have one set of posterior probability. We are going to calculate with another set because we have used 1 minute. We have used this set, but we have not used this set yet. Let's compute. So we do another set for unfavorable market risk report. It is similar approach, but we use this number instead of this number. Okay, look at this number. P1.75, 0.1, 0.75, 0.1, 0.75. This one 0.9, 0.25. Okay, 0.9, 0.25. This is the same. It's the same because we are using this information without market research. Okay, now calculate the same method. 0.8 times 0.1, 0.08, 0.2 times 0.75, and get 0.15. Add it up, we have the sum of the joint probability. So this probability is the probability of unfavorable market report. We put it PU. And then we calculate the posterior probability under unfavorable market research or unfavorable market report. So we calculate this probability PS1 over U 0.35, PS2 under unfavorable or U is 0.65. Okay, what are we going to do with this number? 0.94, 0.06, 0.35, 0.65. So we are going to play with this number.
Choose the best one that will be the that will provide the best result.
Okay. What do you say again, sister?
We pick the one that will provide the best result,
Pick
considering those values of probabilities.
Yeah, but we don't simply pick. We are going to use this to analyze our decision. We are going to use this to analyze our decision. Okay, we are going to use this information. We are going to draw, remember the decision tree that we did earlier. This is the decision tree we did earlier, last class, where you already made the decision. This is the expected value without sample informations. We use 0.8, 0.2, we do the same. So what we are going to do is we are going to branch this out. This is done without market research. Now we are going to branch out. Again, we make another branch, or we call it, we are going to do market research. Okay. So this is the one I showed just now. We are going to branch out to another decision alternative, whether to do market research or no market research. Without market research, we assume this value as the payoff, the best expected value as the payoff if we are not doing any market research. I repeat, If we are not doing any market research, what would be the payoff? So we assume we take from this tree, the highest value is the, as if this is the payoff for not doing research. Okay, now let's look into, if we were to do the market research, we branch again. Now we have this one, market research. We go to these two branches. Remember just now the number which we compute point, okay, 0.94, 0.6. Strong demand, weak demand. Okay, we use this number up here, 0.94, 0.6. The same go for this one for D1, D2, and the favorable report. Okay, look at, we branch from market research. Market research is two likelihood, favorable or unfavorable. Okay, let me flashback. We have favorable, unfavorable. We have 0.94, 0.6. There's the set 0.35, 0.65. So we use this number 0.94, 0.6 on the similar set of decision tree, 0.94, 0.06 for favorable report. We do the same for unfavorable report. So what was the number just now? 0.35, 0.65. Okay, look at it again. 0.35, 0.65. Strong demand 0.35, weak demand 0.65. These are the posterior probability we are using. 0.65, 0.35, 0.65. Under unfavorable report, we also have branched into three decision alternative, D1, D2, D3. So we put this posterior probability here, posterior probability. And this is the same set, Now from here, we do the same, calculate the expected value of favorable report. That means we are calculating this, 0.94 times 20 plus 0.6 times -9. We have this number. The same thing for this one, 0.94 times 14 plus 0.06 times 5. We have this number, and 0.94 times, what number was it up here?
Times
Then
8.
And then times 8 times plus 0.6 times 7, we have 7.94. The same go. From here, we try to select the highest expected value. So if the report is favorable, what will be your decision? D3. D3, because it gives you the highest expected value. The same go when we calculate the second set. The second set is based on unfavorable market report. So we calculate the expected value. Then we do the same. We choose the highest expected value. So if we do not, if the report have some mistake, what will be your decision?
D2.
D2. So D2, the reason is this is the highest payoff. Your decision will be D2. So now, remember just now, the probability of favorable report is 0.77. Probability of unfavorable report is 0.23. So we are going to use this information also. Probability of favorable report is 0.77. Probability of unfavorable report, 0.23. Okay, let's look at it again. 0.77, 0.23. Probability of favorable report, 0.77. Unfavorable report, 0.23. Yeah, 0.77, 0.23. Okay, let's assume the payoff for favorable report, we take the highest from here was it is 18.26. Let's assume this highest expected value is the payoff for favorable market report. And then this 8.15, the highest value here, we assume this is the payoff for unfavorable report. Now let's calculate the expected value of market research. So now we are going to calculate expected value of market research. You have this information, probability and payoff, probability and payoff. So you calculate, you get this number, unless somebody doing the calculating out there. I assume this is correct. So expected value with sample information, or expected value with the market research, we get 15.93. Let's compare this value, 15.93. If we do not do the market research, what do we get? If we do not do 14.2. Which one is better?
With
We
market
do
research.
with market research. So in here, what will be your decision? To conduct market research or not to conduct market research?
To conduct market research.
Conduct market research. Reason, the expected value of market research is greater than without market research. So now we want to calculate the expected value of sample information. What's the difference? This one and this one. So we are calculating what we call the expected value of sample information. So expected value of sample information, expected value of the market research, less expected value without market research. So if we SI, expected value with sample information minus expected value without sample information. So this is what we get. Just your 15.93 less 14.2. This is the expected value of sample information. The same question goes, if this researcher charge you 2 million, are you going to appoint them to be your consultant? You
No.
only no.
No.
No. But if this guy only charge you 200,000, will you appoint him?
Yes.
Yes, because you are to gain this one. So in here, how we conclude this? Okay, one more. Now we are supposed to calculate the efficiency of this sample informations. So the way we do the efficiency is expected value of sample information over this perfect information, expected value of perfect information times 100. In our case, this is one, it's about 54%. Oh, not so good, but not so bad either. So how to know it's very good or not? If you can get this above 0.6 or 0.7, then you are very confident. In here, anything may go wrong. So what's your decision strategy? Your decision strategy, just now you already conclude, we are going to conduct the market research. Present the expected value with the market research is higher than expected value without the market research. So how to verbalize it? So the decision strategy, if market research study is favorable, construct large condominium D3. Otherwise, If market research is unfavorable, then you construct medium, which is D2. Okay. Oh, it's already the end. Any question, brothers, sisters? Are you okay?
Doctor,
Yeah.
I just want confirmation. The expected value that we get is million, right? It's money,
Yeah.
right?
Yeah, money.
Okay.
Money. Okay, good question. When we say we are, let's say we expect value without profile informations, this is just an estimate. We may not get exactly 14.2. We may get it higher, or we may get slightly less. But this value is a guide for us to make decision. So the same thing, this value also, we may get 1.73, we may get 2 million, or we may get less, we may get 1.5 million. But the point is, this value is a guidance, is an analysis to, or as a supporting tool for us to make decision. Remember in our first class, between the cake and the dollar notes, we want to make decision. So when you have managers at different locations, given the same set of information, they will come up with similar decision. That means there is no purely judgment. They can support how, if you go to some other place using the same set of information, you will conclude on the same solutions. So this is important in running a business, especially when you have different set of office and different managers running the business for you. But you want to come up with something, and in order to have a common or systematic approach, that's why we call it decision science. We have a science that support this, and this is logical approach. All right. As I said, this is not exactly what you are going to get. You may get more, you may get slightly less. But you make the decision based on this supporting analysis. Okay, Brother Ahmad?
Okay. How about the efficiency? You said that if it's higher than 60% or 70%, then we can go on, right? But what if it is below 50%?
Below 50%, then it's not efficient at all. It means we have to
So we shouldn't do at all.
abandon the idea of getting these researchers. So this one, we did this pre-appointment, like a due diligence exercise. So if less than 50%, or even at this 54%, you may not really get 1.73. I mean, the payoff here is not so much more. You get here quite significant amount, significant value by conducting this one. It is more worthwhile by engaging these people. For the class illustration, I use the numbers. I think the number come out with these numbers. So, okay, at least the idea is to illustrate the point of getting this consultant. First is one set of consultant. This one is another specialist. Okay, right. Any other thing? No. I need your opinion, whether we finish the class or go for some exercise, simple exercise. exercise that we have done in the last class. Maybe a short, I'm not sure whether we have about 15 minutes. 15 minutes
I might be the minority, but I prefer exercise.
for exercise.
Yeah.
Yes, exercise.
Okay, the others?
Yes.
Just a simple one. Okay, let's have a go. Just a simple one as the warming up. Okay, let me unshare this one first. I will choose. Yeah. Can you see something there? White.
Yes, yes.
Yes.
Yeah. Okay, let's have a go on this simple one. Okay, let's look into these questions. Mirama company is going to introduce what 3 products: a widget, hammer, not. I do not know what are these things. The market conditions, it means the states of nature, will be favorable, stable, or unfavorable. And because of this, it will affect the profitability of the company. So the payoff table is given there. The if market conditions favorable, stable, unfavorable, and the product list, widget, hammer, or not. And you see the payoff 120, 60, 35 for the 3 different alternatives under favorable, stable 70, 40, 30, unfavorable lose 30, make 20, make 20. Now let's play around, determine the best decision using Maximax. So we are going to make the decision. I already prepared this table. So we are going to have widget. Let's say I have this. For you not necessary to have this table. For purpose of online, I will use this one. So let's have widget. Tend too slow. This first. Let's say widget, hammer, and not. Okay, the first one, A, Maximax. What do you have to do?
Just choose the highest value.
Choose the highest value. So let's list down the highest from widget, the alternative.
Favorable 120.
120. And then the next one?
60.
60. 60. You don't have to copy the question. I will put in the item. The last one,
35.
35. No, maximize. What do you do? Maximize.
Pick the highest number.
Maximize the maximum. So what will be your decision?
120.
120. That 120 is your analysis. Your decision. What, 120 or widget? Your decision is not 120.
Widget.
Produce W. Okay. The next one we use B maximin.
Oh, sorry.
B maximin. What's B maximin? What do you do?
Choose the lowest.
Choose the
minimum.
lowest. List the minimum.
Yeah.
So what is the minimum?
Negative 30.
Negative 30. The second one?
20.
20.
And then
The last one?
30.
30 also. There are two 30. Okay. 30. In this case, which one do you choose? Highest?
Maximum 30.
30.
30. Yeah, so 30 just now was 120, the highest. Now, regret. Regret. So maximin already done.
Regret is choosing the minimum out of the maximum regret.
Okay, let's calculate the regret. So let's calculate the regret for widget, hammer, and new node, and the favorable, stable, and unfavorable. Okay, can you tell me the regret here? How much you regret? How to calculate? Take the highest from the column. Look at the column, subtract the highest from each of these. So highest 120 minus 120.
0.
0. So 0, I was about to turn 0. 0, the second one?
60.
60. 60. Last one? 120 minus 35?
85.
85. 85. So this regret for this one. The second one? What number here on the stable widget? 0. Then
30.
30. Yeah.
40.
40. Here, highest is here, easier to calculate. Put 0. Here 10. Here 30 minus negative 30.
Negative 60.
Huh? Negative 30 minus negative 60.
60.
60, right? 60. Agree? Yes?
Yes.
Yeah.
Yes.
So we have this is the regret table. Regret or opportunity loss. Okay, the next thing we are going to find the minimax regret. So what do we do? So we are going to answer C, minimax regret. What do you do? List down the maximum regret. Agree? List down the maximum regret. 60. Where's my 6? 60. The next one,
60.
60 also. 60. Then the last one,
60. 85.
85. 85. So come to frustration. How do you like? You want to maximize your frustration or minimize your frustration?
Minimize.
Minimize. So what happened? You have two options there. So what is your decision? Either one, not both. So you can choose this one. You can choose hammer. So your decision will be widget or hammer. Okay. Now the next one, which criteria? Which criteria? Given alpha 0.04. Now we have this. Which criteria of realism? This is the same thing as criteria of realism. What's the formula? Alpha times maximum payoff plus
1 minus alpha
1 minus alpha times the minimum payoff. This one I need your help to calculate. So now we have to calculate from this table, alpha times maximum payoff 0.4 times 120 plus 0.6 times 130 and write it here. Someone gets 70, something like that. I should get ready with my calculator also. Anybody come up with something? Depend on you all. I'm lazy, brother, sisters. Can you calculate for me?
Doctor is 30.
30.
Yeah.
Okay.
Yes.
Yes.
Okay, let me write. Where is it now? 30. I just do here. This is for D. 30. The second one?
36.
36. The fourth one?
52.
82.
52.
Oh, 52. 5. That's 2. Okay. Now, choose which one? Highest. I'm not sure. The number doesn't seem right. Can double check.
Yes, I got the same answers.
Same answer. Okay, never mind.
Okay.
At least the idea is there. Whether okay, from here, criteria of realism, we choose the what?
The third
Highest.
one.
The third one, the highest, right? We choose the highest. The highest. So what is your decision? Construct. So construct. Produce.
No.
Not. So in any situation, you have to answer what are you doing, not the number. The number is your analysis. Okay, the number is just your analysis. Now the last one, equal likelihood. Oh dear. This one I don't teach you yet. Not fair, right? Okay, never mind. So simple. Equal likelihood here is the likelihood of states of nature, the occurrence of states of nature is equal. So we have here favorable, favorable, stable, unfavorable. How many choices do you have? 3, right?
Yes.
If I say equal likelihood of probability, what is the probability of favorable? 1 over 1 over 1 over 3.
1/3.
This is also 1 over 3. This is also 1 over 3. So what we are going to do is we put the probability of favorable here as 1 over 3, 1 over 3, 1 over 3. So what do? You multiply this probability just like calculating expected value. 1 over 3 times 120 plus 1 over 3 times 70 plus 1 over 3 times negative 30. Or in other way, you put the 1 over 3 on the like a common factor, say 1 over 3 and then 120 plus 70 plus negative 30, you will get the same answer, right? 1/3 is common factor. Do you agree?
Yes.
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 If you agree, then it's easier rather than less work. 120 plus 70 minus 30 divided by 3. Then you get a value. Okay, can someone fiddle in your calculator?
53.33.
So I just put 53.3. The second one, 120 times divided by 3, about 40. Right?
Yes, 40.
40. Let's make this 40. Then the last one, 60, 95 times
23.05.
33. Point,
23.75. 23.
23.
23.75.
23.
Yes, 23.75.
Okay, let me erase first. 23. Yes, I said a bit clumsy. 3.75. Okay, never mind. Put 7. So here the same goes. We choose the highest. Where's the highest here? Where's the highest?
Sorry, doctor. I think the third one is 31.67.
31.67. I'm not computing. I really depend on you. Okay, let me change again.
Yes, doctor. I'm sorry.
What's the number again? What's the number again, sister?
31.67.
31.7. Okay, round it off. So the same goes here. We choose the highest value, and that will guide you to your decision. Where's the highest value? Widget. So 53 and 3. Then you are going to produce widget. Okay, I think it's a good warm up. Warming up a little bit. Are we okay, brothers, sisters? I think we stop here first because we have more later on. After the next one, we're going to use EVPI, EVSI, and that would be a little bit more tedious to do it. Unless you want to do it yourself, then I don't have to worry about it. Okay, we just discussed a little bit. Now, can I take a bit of your time again? Just a little bit of 1 or 2 minutes, 5 minutes. Brother, sister? Okay, I take your time a little bit. This is the first time we do exercise. I think the subsequent time, the exercise is something similar like this. I will have this my slide. I will try create some space for writing like this. A little bit clumsy, but I think better than nothing. Would it be okay to you all?
Yes, doctor.
Yes,
Okay.
doctor.
Yes,
So,
doctor.
Yes, sir.
Yes.
so forgive me for the handwriting, but at least you can read. All right then, shall we end our day for today? Unless there's no question, I will end our day today.
Doctor, what about the attendance?
Oh, forgot to announce. Please put in your chat, put in the chat your metric number and your name, your whatever name, your first name, one name is sufficient. Like the last class, you do the same. So I will take from there. So you please just write in your matrix number and name. It is also tedious on my side. I have to verify one by one and then tick on your attendance sheet. Quite not 37, 42. Any more coming? 45. Good. 48, 49. I will leave the thing on first before I end the meeting. 50. Sign up already. Another 10. 51. Okay, 8 more, please. Since you are already in, might as well sign up. Are you signing up? Another. Okay, no more response. Okay, brothers sisters, I think we have a good day today. Can we end our class? Yep.
Sure, doctor.
Right?
Yes,
Yes.
sure, doctor.
Okay. Okay.
Yeah.
Let's end our class with the recitation of Suratul As. Bismillahirrahmanirrahim. Thank you very much, brothers and sisters. See you again next class on Wednesday. Yeah, most welcome. Most welcome.
Okay, doctor.
Thank you,
You're
doctor.
welcome.
Yes,
Yeah,
sir.
welcome.
Okay, thank you. Bye.
Welcome. Bye-bye. You're welcome.
Doctor, isn't it like the iTaklim has the system for attendance?
I'm not so sure. Any
Yeah,
other
yeah.
lecturer did it?
Yeah, because last semester there are, I mean, majority of the lecture they use iTaklim to take attendance. So like the period only opens up within class period, and you have to take attendance on that day.
Oh, so you have to do multitasking. One is attending class, and one hand you open the iTaklim. Is it like that?
No, you just like, for example, you open iTaklim, and then you
Mhm.
just click that you attended on that day. Just one click, and then basically you are declaring that you've attended.
Oh, oh,
But it's only open for a certain time.
Yeah,
not during class, is it?
it was. I think it was. There's a 20 minutes grace period between before class and even after class.
Oh, I will. Thank you very much for teaching me on that. I do not know about that feature. I will. I will find out how to use it. I will consult people if I do not know how. Then good idea also. Then at least less time wasting
Yeah,
ticking
less
your
less
name.
burden, less burden
Mm,
on your side, of course.
yeah. Okay.
Right, thank you, doctor.
Any. So can I end now? So is Zati there? The rest don't want to show the face. Aiman, Saini, see the face. No, all handsome gentlemen, pretty ladies. All right. I end the class now. Assalamualaikum warahmatullahi wabarakatuh.